And with me, I do have David Fichtmüller from the ABCD project and Gabi Tröge from the Global Genome Biodiversity Network. What I'm planning to present is a short overview of BioCASe, the BioCASe Provider Software. As I understood it, most of the audience are curators, so I'm trying to keep things not too technical. But since I'm a tech person, I might now and then do, so bear with me. As Erika already mentioned, Gabi and David will be standing by in the chat. So if you have any questions or if I skip something or if I'm too fast, just let them know and they will try to answer the questions. As I mentioned, I will present BioCASe and will explain what you can do with it, how you can use it, what are the requirements for using it. Then I will have a short look at ABCD, which is the data standard used by BioCASe. And since I think that many of you or some of you are familiar with the IPT, I will try to point out similarities between BioCASe and the IPT when this is possible. Just for the beginning, regarding the terminology, sometimes there is a confusion about the term BioCASe, the capital E, or whether it's capital or not. This is because the term goes back almost 20 years when there was a project called Biological Collection Access Service for Europe. It was funded by the European Union, and its aim was to set up a European network of biological collections, of natural history collections, and it consisted of several parts. One was setting up a central registry for metadata for biological collections. This has been later merged into Biodiversity Collections Index, then became GBIF, and now it's being passed on to GBIF. Another one was a set of data portals similar to the data portal of GBIF. And these two parts were things that somehow were discontinued. The part that is active until today is the BioCASe Provider Software, which is a publishing software for biodiversity data. And one of the synonyms we use is PyWrapper. And it turns out it's not being used just in Europe anymore, but also outside of Europe. And that's why we got rid of the Europe in the name. And now BioCASe is an abbreviation for Biological Collection Access Service. In a nutshell, what the provider software is able to do is the same as the IPT. So it can publish collection data, or specimens, observation data, any occurrence data from a database or an Excel spreadsheet to a biodiversity network such as GBIF. The source database can be, in the simple case, an Excel spreadsheet or a text file, a simple CSV text file, or it can be also a complex relational database, such as one that is used by an off-shelf collection management system, such as Specify, or something that has been handmade by someone using, for example, SQL Server database or MySQL. Since the data standard used by BioCASe is more complex than the one that is used by IPT, BioCASe is able of transferring richer data than IPT and DarwinCore are. And parallel to this is the thing that also the source database for BioCASe can be more complex than the ones you can use with the IPT. In the IPT, you usually have to have the one flat table of view for the source data, which is the case in most spreadsheets and stuff like that. BioCASe, on the opposite side, is able to publish any data from relational database management systems. That's the thing on the source side. And since BioCASe is able to produce or to transfer more complex data, it can also be used for setting up networks that rely on such richer data. That means that have more things or more data items, are interested in more data items that than Darwin Core. And one example is the Global Genome Biodiversity Network for DNA samples and Europeana. I will show them later. These are two maps showing the current installations of BioCASe. Clearly, there's a focus still in Europe, but you can see that there are quite a few installations in Australia. These are used by the Australian Virtual Herbarium, which uses BioCASe to draw specimens from the individual herbaria into their central cache database using BioCASe. In the left upper side, you see the different special interest networks that are using BioCASe. I think the largest ones are the Global Genome Biodiversity Network, which I just mentioned, and OpenUp. What is BioCASe doing? So similar to the IPT, it can be used to publish occurrence data as a DarwinCore archive. A DarwinCore archive is just a zip file with a bunch of text files of comma separated value text files, together with a meta file, a file describing the metadata of the data set, zipped together as an archive. So the same thing, the same type of DarwinCore archives that the IPT can produce can be produced with BioCASe. But in addition, it also can use the ABCD data standard, which has been originally designed for natural history collections and is therefore more complex and can store richer data. And ABCD is XML based. What the BioCASe Provider Software can do is produce those ABCD documents for the specimens to be published and also place them into one single zip file for harvesting. Both these publication types, DarwinCore archives and ABCD archives, mean that all records published will be placed into one single file for download. That means any network interested in harvesting or in indexing those records must download the whole archive and either ingest it into an index database or parse it or whatever to find out the records of interest. So it's perfect for harvesting a whole data set, but it's not really good for finding individual records of interest. And that's why BioCASe also offers what we call single record retrieval. That means BioCASe features a web service that can be queried with a specific filter. So in this example, if you're interested, for example, just in specimens of Humboldt, so you have a herbarium, for example, which uses BioCASe, and they set up BioCASe and made this access point available. Then you can query this BioCASe web service with this request, and for example, just ask for the specimens that have been gathered by Humboldt. BioCASe will accept this request, transfer it into a format that can be understood by the database, then get back the results, transfer them into ABCD documents, and send them back to you or your data portal or your software, whatever you want to use it for. So that's probably the biggest difference to the IPT, that BioCASe can be used to request single records or range of records, so to say. And you see this type of filter in the request. This can be done with all the data items you publish. So instead of having the gathering agent, the collector as a filter, you could use a collector field number. You could use any identification results, the scientific name, higher taxa, or geographic information. Anything you can publish, you can use as a filter for requesting individual records. The requirements for using BioCASe. Since BioCASe will make the data available as a web service, you need a web server that is constantly connected to the internet so that the data network can drop by in regular intervals and harvest the data. Most of the data providers use Apache. In Windows installation, sometimes Microsoft Internet Information Services are used. It should work with any web server because all it does is just accept requests from the internet, pass them on to BioCASe, and vice versa with the results. I mentioned that BioCASe can accept or can work with source data in simple spreadsheets like Excel or text files, but the most providers, the main usage is with a SQL compliant database. That is a collection database that is behind an off-shelf collection management system like Specify, or something that is used by a system or some database that is used in conjunction with a system that has been implemented by a big institution. And on the slide, you can see the current SQL compliant databases that are used in conjunction with BioCASe, but actually it can be used with any database management system that understands the SQL language. BioCASe has been developed in Python, which is a scripting language. So one of the requirements is that Python is available on the platform you want to use it, but that is the case for all server platforms, including all Linux distributions, Windows Server, and macOS. The steps for using BioCASe, after some preliminary considerations and thoughts you should do, the first thing you will have to do is install it on the web server. As I said, it requires a web server, so if you haven't installed that, you need to install it. The Python language usually is part of most web server installations out of the box. This traditional way of installing the different components required for BioCASe has been, well, it's not really necessary anymore since the Docker way of installing, of deploying software has come up a few years ago. Docker is basically an easy way of installing and deploying software, and it can be compared to the Windows installer that the Windows installers that some of you might know. The difference is that Docker or Docker images, Docker containers contain all the components that are required for a certain software. So in the case of BioCASe, the Python language, Apache, then Java, all dependent libraries will be part of the BioCASe Docker image for installation. So if you use Docker, installing BioCASe will be just one step which installs also all required packages. So that is, if you feel familiar with Docker, it's really just a 2 minutes task to install BioCASe. And it's the same process if you want to update BioCASe later to a new version, or if you want to move it to another installation. This is very easy. The second step after you installed BioCASe is the so-called mapping. So I mentioned that BioCASe uses the ABCD standard to store the occurrence or the specimen data. And in the mapping process, you map the individual elements or fields of this data step, of this data standard, to your underlying source database, to your collection database. That is, you tell BioCASe which field of ABCD, which ABCD data item can be found in which table, in which column in the source database. So I don't know whether it's really easy to read, but if you go down to this, you see that the country code can be found in the collection database in the table collecting event, and the column for this field is gathering site country code name, and the date time, the collection date, can be found in the column gathering date time begin. So that's probably the process that takes the most time, finding out which fields of ABCD correspond to which fields you want to publish. Of course, once you've done that, you will have a look at the resulting ABCD documents and probably find out that they're not yet, that they don't look like they should. So the steps 2 and 3 will be somehow repetitive. So you will go back to the mapping, change some mappings, add mappings, or move them to other ABCD fields, then go forth to the testing and back and forth until the ABCD documents look like you want them to be. Since we're aware that ABCD is rather complex and it's not easy to find the right ABCD elements for your data, there is support available for this configuration process. So if you're unsure of which ABCD field is the right item for something you want to publish, you can contact us and we will try to help you with doing the correct mapping. Of course, that is true for the installation process. So as soon as you start to work with BioCASe, you can get in contact with us and we'll try to help you get it running and getting configured properly. Well, as I said, you can use BioCASe to publish your data as DarwinCore Archives, but in addition, use the access to biological collections data schema, which is more complex than DarwinCore. And this is because it originally was developed for natural history collections, which by nature have a more richer data than usually observations. So therefore, ABCD is a rather complex data standard. It has in its current version 780 data elements plus 240 attributes, which means that you can probably plug in, or you can put in most of the data items you have in your collection database and you want to publish. It is different from DarwinCore, not just in the number of elements it does have, but also in its structure. DarwinCore is a flat data standard. That means that the elements, at least unless you use extensions, can just occur once. That's different ABCD. It has repeatable elements, so that data items that are repeatable for a certain specimen, for example, like multimedia objects. So usually you have more than one digital scan of a specimen. You can put them into the ABCD standard without any additional, well, yeah, you don't have to do any additional efforts. The data standard inherently allows you to store data items that have a one-to-many relationship to the core, to the record base. ABCD has a lot of data items, but still we're aware that there might be very, very special collections and requirements for data networks that haven't been foreseen when ABCD was created. So ABCD has some extension slot, as we call it. This is an element where you can plug in any additional XML data schema. So it can be compared to a Darwin Core extension, unless that with Darwin Core extensions, they must be supported by the IPT, and with BioCASe, it's a bit more a custom-made thing. So you can create your own schema extension or your extension schema with XSD, and you can very easily plug it into your BioCASe installation without having to modify the software itself. And this can be done because BioCASe is agnostic of the data schema used. So you could use it with any XSD schema that you come up and set up your very own network with your own data schema. The current version of ABCD is 2.06, and it has been ratified by TEDWIC. One big difference between ABCD and DarwinCore Archives is that in DarwinCore, you usually have several documents making up the archive. So you have one XML document, ecological markup language, that stores the metadata. And then you have one or several text files, CSV files that hold the actual specimen data. In ABCD, all these information are part of one ABCD document. That is, for example, both the metadata, which cover the whole data set, and the record level data that holds individual specimens or observations are kept all in one document. ABCD is focused on, or was intentionally focused on, natural history collections. So it has special portions that focus on certain types of collections, for example, botanical collections, and it has parts, or it has a part that refer or that are applicable to all types of collections. So on this first slide, you can see on the section record level data that the categories of data that are in this general part of ABCD, and I've just to understand what I've underlined, the ones that are underlined are the ones that in Darwin Core are not part of the core file, but that end up in an extension file. So in Darwin Core, for example, if you want to put in an identification history that is more than one identification for a specimen, you have to use an extension file. ABCD, since it can, it has repeatable subtrees, all these identification results can be put into one ABCD document. The same is true for multimedia documents, literature references, and permits. Yeah, I mentioned that ABCD has specific parts on certain types of natural history collections. Yeah, you can see the list. As we, yeah, of course, by nature, not all of these subtrees are applicable for a certain collection. So if you use, for example, the subtree for a zoological units, you can't use the subtree for herbarium units. Some of these specialized portions also exist as Darwin Core extensions, like preparation, loan, or type designations, and some of them don't have an equivalent in Darwin Core or in Darwin Core or as a Darwin Core extension. I mentioned that ABCD is XML based, so this is a look at a very small, very basic ABCD document. You can see that they're a bit easier to read than CSV files or text files, so you can have a look at ABCD documents and get a good understanding of what the record is about. You can see the catalog number in this case and the globally unique identifier for a record. In this case, it's a material sample. The identification, for example, is collapsed because it's a huge subtree. The same is true for the multimedia objects. And the small, well, triangle to the left means that under these elements, you have whole subtrees with the data items. In this case, as you can tell from the record basis, the specimen is a DNA sample or material sample. And I mentioned that ABCD has this unit extension slot where an extension can be plugged in. And in this case, for the Global Genome Biodiversity Network, an extension has been designed with more information on DNA samples. And that's what you can see under this unit extension item. And if I expand that, you can see that there's more data items, especially on DNA samples, like the type of or the concentration of DNA in the sample, the method, and the date of the DNA extraction, and so on. This is just a part of the DNA or the GGBN extension, actually. For the tech people, you can see or you can tell that these data items are not part of the ABCD standard by the small prefix that precedes the data item names, the tags. So DNA means it's part of the extension, and in the core file you can see ABCD from ABCD that it's part of the actually ABCD standard. Right now there are 3 extensions, ABCD extensions, that are in use. One with probably the most providers is the GGBN extension that you've just had a look at. It is used within the Global Genome Biodiversity Network. And in addition to what you've just seen, the information on how the DNA was extracted and what the concentration is, it links to the results of the sequencing. So it can link to sequencing files, and it can have accession numbers from NCBI and AMBL. So by using the GGBN extension, you can link from the specimen to the DNA and the results of the sequencing processes that have been done. Another extension, which was originally the first one that was created, is the one for geosciences, for paleontological and mineralogical collections, and it's quite huge. It's almost has more elements than ABCD itself, and it is used within the BioCASe network, the Geosciences Collection Access Service, which is a small network for paleontological and mineralogical collections with currently 8 providers. And they have their own data portal with a small indexing database, and the standard has been submitted to TEDVIC for ratification. The last extension that is in use is HISBIT, which is used by the Australian Virtual Herbarium, and it's the smallest one with just 42 additional data items for herbaria and botanical gardens. And as mentioned earlier, it is used within the ABH to draw data from the herbaria into the central ABH database. One of the networks that doesn't use a special extension, but just the ABCD standard, is OpenUp. It stands for Opening Up the Natural History Collections to Europeana. Europeana is the European Digital Library, which is intended to make publicly available digital objects from cultural institutions, mainly to, also a very wide audience, not just for scientific usage, but also to a broad audience. In Europeana, you will find all types of digital objects. Most of them are images. Some are videos. Then there are audio snippets. And I found out it can be compared to the Digital Public Library of America, and the portals even look a bit alike. So they're probably the same. OpenUp is currently the second largest aggregator for Europeana, and it publishes about 9 million objects from 29 institutions. Europeana is not just interested, or doesn't just publish data from European institutions or from European dataset, but also all objects that have some relevance to Europe. So one of the institutions within OpenUp that uses BioCASe is the Chicago Field Museum, which publishes about 16,000 photographic negative of type specimens to Europeana, and the story behind this is quite interesting. These photographs have been taken in the 1920s, 30s by Francis McBride, who traveled to several European herbaria to take photographs of type specimens. The intention of this was to allow American botanists to use or to have access to those types without traveling to Europe, because many of them couldn't afford. And then in World War II, the Berlin Herbarium was largely destroyed, apart from a few specimens that had been relocated before. And so many of those types have been destroyed. And well, the photographs are all that is existing now of these types. And thanks to the Chicago Field Museum, these high-res scans of the types are available in Europeana now. Well, until now, I've been talking about ABCD2, which is the current version in production of the standard. In the past years, a new version has been developed, ABCD3, and whereas ABCD2 was just an XML schema, ABCD3 is also an XML schema, but also an ontology, which means that it's not one monolithic standard that has to be used, but if you want to use, or if you plan to use ABCD3, you can pick the parts of ABCD that you want to use. So you can just use certain terms of the ontology and are not restricted to using the whole thing and just ABCD. Plus, it can be used for publishing your data in RDF. which is a way of publishing data that has come up in the past years too, and is a good way of interlinking data from different communities or from different domains. One of the most important changes between ABCD 2 and 3 is that it has a lot of elements for storing or for publishing URIs to external stable identifiers. And this has the big advantage that you can publish data without adhering to any textual representations. Or for example, if you take the collector of a specimen, Humboldt, you typically in a collection database, you will have dozens of different versions of how the name has been spelled in the past, which makes searching these data, these specimens, difficult. And by linking all these specimens to an identifier for the person Alexander von Humboldt, you can overcome this problem. So it doesn't matter anymore how the name was spelled by the one who entered the data into the database, but by linking it to the person, to the identifier of the person, you can make searches more, well, you can make the results of searches better, and it's easier to interconnect your data with data from other institutions, for example, if they use the American way of abbreviating names, for example. ABCD3 has been published a year ago and is not in production use yet. It has been submitted to TEDWIC as a standard, and not yet, but it's planned. So ratification as a TEDWIC standard is planned, but it hasn't been submitted yet. Well, both data standards are, or both the IPT and BioCASE are tied to data standards. So BioCASE usually is used with ABCD and IPT with Darwin Core. And for almost 20 years, these have been two competing standards which have their origins in different communities. And for this, one of them is more complex and has a focus on rich data and high completeness, whereas the other one is lighter and simpler. But this gap has been closing in the past years. So Darwin Core on one side, for Darwin Core, more terms have been added. So it now has, I don't know, about 200 terms or something like that. Classes have been introduced, and by using extensions, you can have repeatable elements published in DarwinCore Archives. So it is flat, but you can still publish repeatable elements for certain records. ABCD3, on the other side, has become an ontology, so it's not a monolithic standard anymore, and the number of terms has been reduced by reducing terms amongst different classes. So there are plans of merging both standards into one single standard, and until now there has been an expressed interest by the stakeholders, and the way to go forward is to form a TEDWIC interest group in the near future. I said that I wanted to try to point out the similarities or differences between BioCASE and IPT, and this is a small overview with that purpose, for that purpose. So one of the advantages or of the features that IPT doesn't have is that BioCASE is web service based. That means you can always request a latest version of a record, whereas with the IPT you need to download the full record, the full archive, and if you have a huge data set, you need to regularly create those archives and download them for a latest version. For this reason, because IPT is archive-based and BioCASe is web service-based, this comes with the advantage that you can harvest a data set partially. If you're interested only into certain records, you can request only those records by using a BioCASe filter. So you can decide which way of harvesting or accessing records by yourself. Either you use the archive method if you want to harvest the whole data set, or you can use the web service if you're interested just in certain records. ABCD is a very comprehensive data schema. So with BioCASe, you can publish very rich data, and connected with that is that BioCASe can connect to fully relational data sources. That means you can publish data directly from your collection database and don't need to transfer it to a single table or a view. Downside, or one of the downsides that have been around for a long time, is that it's rather difficult to understand, to install, also to understand sometimes. And this has been eased by Docker lately, so that's why it's a bit gray in this slide. It is definitely less user-friendly due to its complexity. So if you want to use BioCASe, you have to dive into the ABCD standard and the multitude of its elements, and creating the mapping is a bit difficult sometimes. And due to the XML nature of ABCD, the amount of data that is produced of the documents, the size of the documents is quite huge. So it is slow for huge data sets with millions of records, for example. It shares the downside with, or the disadvantage with the IPT, that there are no data quality checks included in BioCASe. And because it's not aimed, or it's not targeted just for GBIF, it doesn't have any connection to the integration of the GBIF registry. So if you set up BioCASe and want to use it to publish your data to GBIF, you have to inform GBIF manually. You have to register your data source manually with GBIF. As both the standards ABCD and DarwinCore converge, there are also plans of merging both publishing software toolkits. So merging BioCASe and IPT into one product, or into a suite of products. And as with merging ABCD and DarwinCore right now, they are just plans. The stakeholders have expressed their interest, and in first discussions, a lot of questions have come about the different approaches, and it will be probably a rather long process of agreeing on a way to implement this, but there are plans to converge, to merge BioCASe and IPT in the near future, or in the not very near future, actually. There is comprehensive documentation on BioCASe on the BioCASe wiki. It has a sort of a beginner's guide which explains the basic concepts behind BioCASe, the requirements, then the considerations you have to do before you start using BioCASe. It explains how to install it, either the traditional way or using Docker. It explains step by step how you create the mapping between the ABCD standard and your source database, how to debug an installation or a mapping. And then there's a huge list of frequently asked questions that I compiled over the past years. So I got a lot of requests from users of BioCASe having problems or how can I do that? And every time a question came in, I put it onto this list with the answers. So there's a good chance that this will help you when you run into problems with BioCASe. Yeah, that's it. Thanks for your attention. As I mentioned very shortly in the last slide, there's a comprehensive documentation on BioCASe. You can find it either directly go to the wiki of BioCASe, which is the second URL on the down left corner, or you just go to the BioCASe webpage, which tells you a bit more about BioCASe and the ABCD standard and the network, and also links to the wiki, of course. And as I said, if you have questions, you can contact us and we'll try to help you well, with your basic considerations, whether BioCASe is the right option for you, and any concrete questions on installation and configuring. Erika mentioned the survey, which you can take after the webinar. And one of the questions that will be part of this survey are if you're interested in a follow-up webinar. This one was rather theoretical and just slides and slides and slides. And what we could do or could offer is a more hands-on webinar, which shows you how you install BioCASe, how you do a mapping between a simple source database and ABCD, and what it looks like in production. So if you're interested in such a follow-up webinar on BioCASe or the ABCD standard, make sure you fill out the questionnaire, and we would be happy to offer that as a future Darwin Core Hour.
Thank you so much, Jörg. That was really wonderful, and I want to echo your recommendation that please do let us know if you'd like to hear more about ABCD and BioCASe and the convergence of those between Darwin Core and the IPT, because we would like to be able to speak to those topics in Darwin Core Hour if people are interested. We do have 8 minutes or so for the rest of this hour, and so if anyone would have questions for Jörg or his colleagues, please feel free to ask them either in the chat or unmute yourselves and use the microphone. While people are, or go ahead, Deb.
I have a question, just because I'm learning, so bear with me. I was trying to understand the example you gave where we can search the files, we can filter on your files for a given set of data, so we don't have to pull down the entire archive. Is that right?
Well, you don't search on the files, but on the database itself. So it's like querying a database, and you can query the collection database through the BioCASe web service. So just the records that match your filters, in this case Humboldt, will be loaded from the database and then transferred into ABCD. So it's sort of on-the-fly generation of ABCD documents.
Yes, I would like to learn more about that and see that in action. If that's my request.
Yeah, that would be part of the follow-on webinar. Yeah, I can do that.
I have these dreams of being able to do more SQL-like type things on top of these large data piles, where I could ask for values from a particular field, for example, or I could do as you suggested, just find all of a particular collector or data from a certain area. And it's harder to do in these big blob databases where you have to download all of the data to do as you suggested before you can do just the part you want.
Yeah.
So I'd like to see that.
So you can, as I mentioned, all the records or all the data items you publish, you can use in a filter, and all the types of operators you have in a SQL statement you can use in a BioCASe filter. So you have something like equal, larger than, less than. You have like operators. You can
distinct.
Distinct. You can combine with or and. So you can create a complex query.
Oh, yes. Okay, that's my request. I'm going to
Which depending on the underlying database and the indexes that exist can be slow, but you can do it.
Yeah, that's cool. Gary, do you want to talk about what you said? I don't, what are you quote when you tell us you're going to quote spin up GeoCase for use by? What's going on?
So the Indiana Geological Survey and the IU Paleontology Collection at Indiana University are looking at extending a lot of the services and the features that BioCASe has done in this presentation for the geo collections community. And since it has been such a cyber infrastructure limited task for many organizations and their collections, what my group is planning to do is to actually take the cyber infrastructure as a whole and containerize it within a Dockerized environment. So not only are we going to take the GeoCase application and everything and bundle it with the Python dependencies, but we are going to pre-wrap it with the metadata schema from CSAR as well as from ABCD, EFG, and build that into a sort of a collections management system that is free and open source. So we've gotten funding to develop this and are looking to extend that application so that we can ensure that we have a collections management system sitting alongside a digital asset management system in a framework and metadata schema that's bound to the schema and eventually the ontology as BioCASe has done, and really starting to think very deeply about this workflow where we can put this out sort of as a platform as a service kind of service for the geo collections community, because we've learned pretty substantially from the bio collections community here.
May I ask a question?
Indeed.
You mentioned, or you said that you wanted to Dockerize GeoCase. So do you mean the provider software or the data portal?
That is a little bit more for discussion later. So
okay.
Well, yeah, I'd be happy to talk with you offline about this later.
Sure.
Erica, I noticed you typed in there, and who else? Christian, do you?
Yeah, I think both of us were curious, and Gabi just put something in the chat, but the work that's being done to see where ABCD and DwC might converge, who is leading that, or if people wanted to participate in a future TADWIG interest group on that topic, what actions are leading towards that, or who's working on that?
I'm not sure who wants to answer that.
I think I can answer this. Hi everyone. There has been a call in, I think it was June or July of last year, with a lot of people who are involved in the ABCD, DarwinCore, and similar data standards that was led by Stan Bloom. And he basically got all of the people together for the first time and sharing ideas on how to on how such an approach could work, and if there is interest. And the main takeaway from this meeting was that there is a general interest from all of the people just to say, okay, these standards have gotten closer together. Let's try to move forward and let's actually converge them. So it's a better practical approach to being able to work with both standards side by side, or even maybe as a combined standard. However, there are a lot of details still open, and there hasn't been that much work in the past month. Actually, there was a presentation by Stan Bloom at Biodiversity Next last year, and I was trying to find the link to the abstract, but I couldn't in the quick time between the question being asked.
I'll have a quick look.
Yeah, we will certainly find it and post it in the chat. So Stan Bloom is in charge, and there is expressed interest from different partners, but there's nothing really concrete. That basically like gathering approaches how this could work, and but still no clear direction in which way this should go.
Thank you for that. I do want to note that it is the end of the hour, and so I'd like to be respectful of people's time and call this for today. But thank you very much, Jörg, David, and Gabi. And please fill out the post-webinar survey and let us know if you'd like to have round 2 of this webinar, because I think that might be very useful.
Yeah, thanks for
note
giving
that,
us the opportunity.